Hello. Today I'm going to be talking about how some aspect of mechanical engineering can impact urban sustainability. But before I get into the mechanical engineering aspect of this, I'm going to talk a little bit about what urban sustainability actually is. Because quite frankly, when I was given this prompt, I had to Google what urban sustainability was because I had no idea. Urban sustainability, by definition, is the idea that a city can be organized without excessive reliance on the surrounding countryside and be able to power itself with renewable sources of energy. The aspect of mechanical engineering I chose to analyze is efficiency. More specifically, designing for efficiency. To illustrate my point, I'm going to be talking about the efficiency of various different kinds of motors, and how the efficiency of motors has generally gone up over the past 2 decades, as well as the designs responsible for the increase in efficiency. The first kind of engine I'm going to talk about is a gasoline engine. I'm sure most of you are familiar with a gasoline engine, but I'll go over it anyways. A gasoline engine basically uses fuel that's mixed with air, which is then compressed by pistons and ignited by sparks from spark plugs. This ignition causes combustion, and that combustion causes the gases to expand and push the piston during what is known as the power stroke. And this, in turn, powers your vehicle. This type of engine more generally is called an internal combustion engine. This type of engine is typically around 30 to 40% efficient and releases a lot of pollutants into the air in the form of exhaust. Although this engine has been improved over the past 30 years, it's still probably not the best choice due to the large stream of pollutants that tend to come out of the engine. This, coupled with a relatively low mechanical efficiency, means you waste a lot of energy, it costs a lot for you to maintain, and it's bad for the environment. Therefore, also bad for urban sustainability. The second kind of engine I'm going to talk about is a diesel internal combustion engine. This internal combustion engine works slightly differently than the gasoline one. In a diesel engine, there is no mixture of fuel and air. There is only air that is compressed. Then, once that air is compressed and heated up to a suitable temperature, fuel is sprayed into the hot compressed air at a suitable measured rate, causing it to ignite. After that, the process is pretty much the same as the internal combustion engine for gasoline. This variation on the internal combustion engine has a 40 to 50% efficiency and requires lower grade, less processed fuel. This means the fuel is less expensive to buy because it has to go through less refining before it goes into the engine. The downside is, if you happen to accidentally put gasoline into your diesel engine, it will explode, which honestly is not much fun for anybody. In addition to that lovely side effect, one of the other downsides is it still pretty much releases the same amount of pollution. So it's basically just as bad for the environment. The only thing is it costs you a little bit less money and it takes a little bit less to refine it. Although this is an overall improvement, this is by no means a solution to the low efficiency problem that we currently have with motors. The final type of motor I'm going to be talking about today is the newest kind and honestly the most promising. This is the electrical motor. Now, I don't know too much about electrical motors, so I went and looked up the only company I could think of to implement a fully electrical motor. This company is Tesla. The 2012 S Performance Tesla model has a 3-phase, 4-pole AC induction, 416 horsepower, and 443 feet per pound rear-mounted electric motor with copper rotor. Now, if you're like me, you'll have absolutely no idea what that means. So, I did some research and found out that, basically, the entire motor is powered by a glorified rechargeable battery. Now, before you write it off as garbage, there are actually quite a few merits to this. First of all, the electrical motor weighs in at a whopping 90% efficiency. This is more than double the traditional gasoline motor and also close to double the diesel engine. The mileage on this car also isn't so bad. You can get 200 miles on one charge of this battery. To put that on perspective, a full tank of gas in a midline Prius gives you about 600 miles. So, that's pretty good because it doesn't cost very much money to recharge the battery. However, the major upside is, for the environment because it's relatively exhaust-free except for, the exhaust from the power plant that you're getting the electricity from, but that's minor compared to the exhaust you would be emitting normally from a regular car. In conclusion, mechanical engineering has a positive impact on urban sustainability because it increases the efficiency of cars and motors and decreases the negative impact on the environment. And that is all. Thank you.